Hey guys, I thought I'd come and do a little video for you guys with this series and sequence problem. So let's have a look at this. Start with A. Ashley trains for 12 hours for the first week. She decides to increase the amount of time she spends training by 2 hours each week. Find the total number of hours she spends training during the first 15 weeks. Okay, if I've got a written question like this, the first thing I want to do is have a look what that sequence looks like. So let's start here. Week 1, we've got 12 hours. What's she going to do in week 2? She's going to increase her training by 2 hours. So the next week she's going to train 14 hours, next week 16 hours, next week 18 hours, and so on. So we can see a nice arithmetic sequence there. Arithmetic. Okay. So now we know we can apply anything we know about arithmetic sequences and series to this situation. Okay, so now I go to the question. Find the total number of hours she spends training during the first week. Total number of hours. So we need to ask, are we after one of the specific terms, or do we want the sum of those terms? Well, I think you guys would see we want S15. Okay, so make sure you check your formula booklet. For arithmetic sequence, we know that Sn is equal to n over 2, 2a plus n minus 1 d. So we need n, a and d. Well, let's have a look here. What have we got? A for our sequence is 12. Our common difference is 2, and in this case, n is 15, since we want the total number of hours for the first 15 weeks. So let's put those in now. So we've got 15 over 2, 2 lots of 12, plus 15 minus 1, so 14 lots of 2. A little bit of math there. We end up with 15 over 2, 24 plus 28. Don't need to mess around any longer. We get 390 hours. So over the first 15 weeks, she spends 390 hours. Now there is an alternative way of looking at this, and that is using the other formula where we have Sn is equal to n over 2, a, or a lot of you like to see u1, plus un. So we could actually find, if we want S15, we want 15 over 2, a, which was 12, plus term 15. Well, can we find term 15? Yeah, sure we can. Term 15, un equals a plus n minus 1 times d. So we've got u15 is equal to, what do we got there? What's a? 12 plus 14 times 2. And we end up there with 40. So if we go and put that in here, we get 15 over 2, 12 plus 40, and surprise, surprise, we also get 390 hours there. Okay. All right, let's have a look at the second one. Right, Billy, her training partner, trains for 12 hours for the first week. So I'm going to put here, week 1, 12 hours. She decides to train for 10% longer each week. Okay, so if you're increasing something by 10%, you're finding 110% of that amount. So I want 110% of 12, or 1.1 lots of 12. And then in week 3, she wants 110% of this amount. So 1.1 times 1.1 times 12. So 1.1 squared times 12. Multiply that by 1.1 again, we'd have 1.1 cubed times 12, and so on. If we have a look at that, we can see we've got a geometric sequence here, geometric, where a is equal to 12. Our common ratio, we're multiplying each of these by 1.1 each time. Okay, so we know what we've got, we can now work with it. So show that in the third week she trains for 14.52 hours. Okay, so are we after a sum or are we after a term? Do we want an SN or a UN? Show that in the third week. So we just want the third week data. So we're obviously after a term in the sequence. Well, let's go right here. 1, 2, 3. There's week 3. So we want U3, which from our observations here is 1. Pen problems again. 1.1 squared times 12. And when we get that, we end up with our 14.52. But if you didn't have this set up already, and you can see the advantage of having that, you can say, all right, UN is equal to AR to the n minus 1. We want U3. A is 12. R is 1.1 to the 3 minus 1. And there's your 3 minus 1, 2, exactly the same as what we've got there. And part 2, it says find the total number of hours. Total number, we're thinking about sum again. She spends training during the first 15 weeks. I'll just come over here a little bit. In this case, we want S15. All right, so we can use our formula. Sn equals A R to the n minus 1 over R minus 1. No excuse for getting those wrong. They're in your formula booklet. So when we whack those in, we've got 12, 1.1 to the n minus 1. Notice there's 2 here. The reason I'm using this one is because the common ratio is bigger than 1. If the common ratio is smaller than 1, I would write this as 1 minus r to the n over 1 minus r. Okay, but they do the same thing ultimately. Over 1.1 minus 1. Little bit of math there. You can put that straight in your calculator and we get 381.2697 blah 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 blah. So when we're talking about hours, that's approximately 381 hours of training. All right, guys, and our last one. In which week will the time Billy spends training first exceed 50 hours, be more than 50 hours? Okay, so let's have a look at that. We want to find an N. We want to find the week, the position in the sequence where it exceeds 50 hours, which her training first exceeds 50 hours. My goodness me, that's a lot of training. Okay, so we want UN to be greater than 50. All right, so once again, we've got a geometric sequence. We know that AR to the n minus 1 has got to be greater than 50. We put our A and R in, so we've got 12 times 1.1 to the n minus 1 has to be greater than 50. So what we're going to focus on now are the different ways we could solve this equation where our unknown is in the exponents. You might want to look at it and say, oh, I'm going to use logs. So let's have a look what we might use if we were using logs here. Let's just neaten this up a little bit. I'm going to get rid of the 12, divide both sides by 12. So I've got 1.1 to the n minus 1 is greater than 50 over 12. Notice I'm not going to get a value, I'll just leave it at that. Now I'm going to play with my exponents for a little bit. You don't have to, but I'm just showing you one way to go about it. That's 1.1 to the n divided by 1.1, isn't it? When you're subtracting exponents, that means you are dividing. It's greater than 50 over 12. So I'm going to shift that up there. So I've got 1.1 to the n is greater than 50 times 1.1 is 55 over 12. And so now we want to solve this, don't we? Okay, let's have a look what logarithms would be there. We want to find the exponent. Okay, so I'm going to solve this. Solve 1.1 to the n equals 55 over 12. Using our logs, we know that our exponent n equals the log of this base here, our 1.1, 55 over 12. So the log of 55 over 12 base 1.1 is equal to n. Of course, use our change of base there. We get the log base 10 or log natural, completely up to you. 55 over 12 divided by log of 1.1. And when we get that, we get approximately 15.9 blah, 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 blah. So if it takes 15.9 weeks to get to 50 hours, then how many weeks does it take her to exceed the 50 hours? Would that be 15 hours or 16? If it's 15 weeks, she's going to be under the 50 hours, so we have to go up to 16. So it'll take 16 weeks to exceed her 50 hours. Wow, that's more than a working week. Busy girl. Okay, now there is another option, of course. Now let me see. Let's get the calculator up here. We could do it graphically. Right, what I've got up here, I have graphed. I'll just write this down. I've graphed y equals 1.1 to the x, and y equals 55 divided by 12. That's all I've done. Where are we? Come up. Okay, here's our 55 over 12. Let me just go and show you that. 55 divided by 12 and 1.1 to the x. I've just graphed those. And what I'm going to do now is find this point of intersection here. So I go to my calc menu, second start, and I'm going to go down to intersect. So 5. First, I'm too close to see that. First curve, yep, that's on the linear one. So enter. Second curve, yep, that's on our exponential. Guess, oh, it's about right. There we go. So once again, we get that intersection point was 15.9 blah, 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 blah. And of course we round that up to 16. Okay guys, hope that helped.